A hidden river in the ocean controls the weather of the entire planet. Right now, beneath the surface of the Atlantic, a river is flowing, a river with no banks, no bridges, and no name on most maps. It carries more water than every river on land combined: the Amazon, the Nile, the Mississippi, all of them together, many times over. You cannot see it from the beach, yet it decides whether palm trees grow in Scotland and whether the rains arrive on time half a world away. And here is the unsettling part. This great engine appears to be slowing down. Scientists call it the ocean conveyor belt, a single planet-sized loop of moving water that connects every ocean on Earth. This is the story of how we found it, what drives it, and what happens to all of us if it ever stops. Our story begins in the 1770s with a puzzle about the mail. Benjamin Franklin, then in charge of the colonial post, noticed something odd. Mail ships sailing from England to America took weeks longer than ordinary merchant ships. The answer came from his cousin, a Nantucket whaling captain named Timothy Folger. Whalers knew about a powerful warm current sweeping across the Atlantic, and they knew that fighting it was like walking the wrong way on a moving walkway. The merchant captains rode its edge or dodged it. The English mail captains sailed stubbornly straight into it. Franklin and Folger drew the current onto a map and gave it the name we still use today, the Gulf Stream. On later voyages, Franklin dangled a thermometer over the ship's rail and watched the water suddenly warm as they entered the stream. One of the first ocean measurements ever made. What those sailors had found was staggering. A ribbon of warm water dozens of miles wide, moving faster than most people can swim. Off the coast of Florida, it already carries more water than all the world's rivers combined, and it grows even stronger as it charges north. But what makes an ocean flow like a river in the first place? At the surface, the answer is wind. Steady trade winds drag the water forward, and the spin of the Earth bends its path into vast circling loops. Yet wind only explains the skin of the ocean. The true engine lies in two humble ingredients: temperature and salt. As the Gulf Stream's warm water travels north, the sun and wind evaporate some of it away, and the salt stays behind. Mile by mile, the water grows saltier, and salty water is heavy water. Then, in the seas near Greenland, Iceland, and Norway, the Arctic air steals its warmth. Now the water is both cold and salty, so dense that the sea can no longer hold it up. And so, in a handful of special places on Earth, the surface of the ocean simply sinks. Colossal columns of water plunge toward the abyss, like slow-motion waterfalls hidden inside the sea. Every drop that sinks pulls more warm water north to take its place, a pump with no machinery, powered by nothing but physics. That pull is the heartbeat of the whole system. Sinking in the north drives a conveyor that circles the entire globe. So where does all that sinking water go? It piles onto the floor of the Atlantic and begins to creep south. Cold, dark river crawling beneath the warm one flowing above it. It slides along the bottom of the world, joins the currents that circle Antarctica, and spreads into the Indian and Pacific Oceans. There, over centuries, it slowly warms, rises back toward the light, and begins the long ride home along the surface. Oceanographers estimate that one full lap of this loop takes roughly 1,000 years. Think about that. A drop of water sinking off Greenland today may not see the sky again until the year 3000. Some of the water lapping at your feet on a beach holiday last touched air when knights were still building castles. We even owe part of our map of these currents to a shipping accident. In January 1992, a storm in the Pacific washed a container off a cargo ship, spilling nearly 29,000 plastic bath toys into the sea. For years afterward, yellow ducks, blue turtles, and green frogs drifted ashore from Alaska to Australia, and some even crossed the Arctic into the Atlantic. An oceanographer named Curtis Ebesmayer tracked the toy landings like clues in a detective story, using them to test and sharpen our models of the currents. The ducks proved what the science had long suspected. There are no separate oceans, only one great connected body of water endlessly stirring itself. So the ocean moves, but why should that matter to someone living far from the sea? Because this conveyor is not just moving water, it is moving heat, planetary quantities of it. The Gulf Stream system carries roughly 100 times more energy than all of human civilization uses. That heat is a big part of why Western Europe enjoys winters far gentler than its latitude deserves. London sits farther north than almost every major Canadian city, near the latitude of Labrador's icy coast, yet its winters stay mild and green. On Scotland's west coast, gardeners grow palm, like trees outdoors, a gift of warm water that began its journey in the tropics. The currents feed us, too. Where deep water rises back to the surface, it hauls up nutrients that have been raining down into the dark for centuries. Those nutrients ignite blooms of plankton, and plankton feed the anchovies, sardines, and tuna that make these zones the richest fishing grounds on Earth. And the sinking water performs one more quiet miracle. It drags dissolved oxygen down into the deep. Every strange creature of the abyss, every anglerfish, every ghostly octopus can breathe because the surface ocean keeps sinking. The conveyor even helps decide where the rain falls, steering the bands of tropical rainfall that billions of people depend on for their crops. Take away this circulation, and you don't just change the ocean, you rearrange the weather of the whole world. Which brings us to the question scientists are quietly worried about. Could the conveyor actually stop? It has happened before. Around 12,000 years ago, as the last ice age ended, a colossal lake of glacial meltwater burst into the North Atlantic. All that fresh water diluted the salt, the great sinking stalled, and many scientists think that is what hurled the region back into deep cold, a lurch known as the Younger Dryas. Ice cores from Greenland suggest the climate flipped within decades, a planetary switch, not a dial. Today, something eerily familiar is happening in those same waters. Greenland's melting ice sheet is pouring fresh water into the very seas where the great sinking takes place. In 2021, researchers reported that the Atlantic circulation appears weaker than at any time in about 1,000 years. South of Greenland, there is now a patch of ocean that has stubbornly cooled while the rest of the planet warms, a cold blob sitting exactly where models said a slowdown would leave its fingerprint. Hollywood once turned this into an overnight apocalypse of instant ice. The real risk looks nothing like that. Instead, scientists expect a slow unraveling. Harsher European winters, shifting monsoons, faster sea level rise along North America's east coast, changes unfolding over decades, which on a planetary clock is the blink of an eye. No one can say for certain where the tipping point lies, and that uncertainty is exactly why researchers watch this current the way doctors Watch a heart beat. So the next time you stand at the edge of the sea, remember what you are really looking at. Not scenery, but the circulatory system of a living planet. A 1,000-year river that warms continents, feeds the deep, and holds our weather in its hands. Follow Worth Knowing for more things worth knowing.